Hey, what's up? How are you? Good?
Let's get started. So thank you all for coming. I'm really excited to be speaking here. My name is Stuart Larsen, and today we'll be presenting on content security policy reporting and aggregation. This talk is Caspr and Friends. So today I'm going to talk about a couple different things. I'm going to start out with the same origin policy, pretty much like every security talk related to browsers. We're going to talk about content security policy, what that is. I'm just going to give a brief overview since it's been covered a lot. Then we're going to jump right into violation reports. In the violation reports, we're going to talk about how to use them, what to do, and what sort of information you can glean from all these reports. And then we're going to talk about some of the tools I built related to content security policy and how you can install content security policy on your website and make it a lot simpler to use. So, quick thing about myself. I actually just graduated college a couple months ago. Been programming since I was about 12, and 2 weeks ago I started my first big boy job at Yahoo. Woo! Hey boss.
Don't shoot up.
I'll learn some. Yeah, been programming for a while, and I love my programming. My mom one day asked me like, why can't I read porn like a normal boy? I always have a computer book in my hand. That being said, I also like to build things. I've been building crap since forever. I run dating websites, catback spamming websites, programming helpers, X509 generation, like you name it, I've probably built something related to it. So, getting started, first thing we're going to talk about, same origin policy. Pretty much every talk about browser security talks about same origin policy, so I'm pretty sure most of you are familiar with it. But just the general idea is that when you visit an untrusted site, that site should be able to manipulate your sessions that you've already pulled in one of your trusted sites. And so, basically it says no DOM access to other websites. And so this is nice because it gives each developer a little play area that for them to build a website and not have to worry about other sites messing with it. And so if we didn't have same origin policy, stuff like this would be possible. This isn't real code. It's just kind of pseudocode. And obviously this doesn't work because we have same origin policy, but you can see if a user was to go to first their mybank.com, authenticate, and then go to evil.com, evil.com would be able to do something like this, where you see the title is evil and they have the script, and they are able to grab the CSRP token. We're not going to cover CSRPs in this talk, but if you don't know what that is, I'll look it up. It's a pretty common attack. And then they would be able to make requests on your behalf from that tab to like transfer money or do anything that the client would be able to do. So obviously it's great that we have same origin policy. So, but since we have same origin policies, hackers have still been trying to get around this, and one of the ways that they've been successfully getting around for a while is a thing called cross-site scripting, which is XSS. And the idea behind XSS is browsers trust pretty much everything it receives, the content it receives from the server, like it should. When you go to Facebook.com, you expect to get Facebook.com and execute scripts from Facebook.com, which is good. And so XSS makes the scripts like it came from the server, and so the browser executes those scripts like it should. So another example that doesn't work, thank God, is you can imagine yourself on Twitter typing a status like, so excited for AppSec Cali, CSP for life. And when you post this, right underneath you'll have your little tweet box, and you'll be able to see it like, yay, it got posted and it got rendered within the HTML. So a malicious person could potentially try something like this, where so excited for AppSec Cali 2015, and then have a script source, evil.com/evil.js. And so if Twitter was vulnerable to this, this would obviously, the script source would get rendered in the HTML and then would be executed, and they would be able to execute any code that they had hosted on evil.com, which would be a very bad thing. Fortunately, this doesn't work with Twitter. Yeah. So a couple quick types of XSS. The one we just looked at was called a stored or persistent XSS. There's two others. There's reflected, non-persistent. This is usually done through like a URL message. So like you have an error message page. So like if something goes wrong on the server, it'll just send this back, and this message gets reflected. So it just gets, the server takes that message, error message query string, puts it into its HTML, and gets rendered with like a big red box or something. And so hackers can sometimes put like a script source in there, and it just gets reflected. And then we usually use a URL shortener. Fortunately, you don't see too many of these anymore, thanks to things like XSS Auditor and WebKit. It seems to kind of be dying out, just from my experience. And then the last type is DOM-based. In this example, the server doesn't actually participate. the server will respond. So the client will ask for example.com with this default query string with an XSS injection, but the server doesn't actually handle it. It's all done on the client side, so the client side will like window.location, grab the query string, and do something with it, and like put it into the DOM itself, but the server doesn't really play with it at all. This is all done on the client side. So obviously this is a big problem. Normally during this talk, people would talk about or give a statistic about how bad XSS is and how many millions of dollars are lost or something. But I think we all know that this is a big problem. And so a bunch of smart people got together, maybe some people in this room, and they wrote a draft. I don't recognize anyone, but I don't know too many faces. But a bunch of smart people got together and they created a thing called content security policy. And that's what this talk is about, and the reporting. So content security policy, the official definition is what's written up there, but the idea is that your website can tell the browsers what content it should allow and which content it should, and it specifies the intent of the website. And so in this thing, it sends down the policy. I write down CSP policy. I know that's like ATM machine, but when I say policy, I mean like the actual policy string. So the server sends down this policy along with the website. They can send it in either an HTTP header or a meta tag. And what the policy says is, hey, I only want you to download JavaScript from these valid sources like a.com or b.com. Only download CSS from a.com, and only download images from these sources. And don't download anything else because it's a whitelist. So if the browser came across something like evil.com/evil.js, this would not be rendered. And so in more official terms, you'll have a list of directives and values. So you have content security policy, and it'll have something like default source, which just means if a directive is not explicitly listed later, use this fallback of self. And self means you can load anything from the same origin, which is, an origin is defined by scheme, host, and port. That's the uniqueness or tuple. So then you also, like a script source, this is where you can download scripts from. So for this example, you can download scripts from self, from jQuery and Bootstrap, and then you can download styles from Bootstrap. And the report URI says if there's any violation, if the browser encounters something that it shouldn't be able to handle, or it shouldn't, if it gets like evil.com or something like that, it's going to send a report to Caspr.io endpoint. So I put up all the directives. I don't think we need to cover them. Most of them are pretty self-explanatory. Like we just talked about default source and script source. You can kind of guess like script source only allows scripts from these places, images, styles, fonts, connects. These all make sense. For connects, connects can be WebSockets, AJAX, or event sources. 3 different mechanisms the browsers use. And then there's a lot of advanced directives, especially in the new draft. Media kind of goes up with the previous page. There just wasn't room. Media is anything in a video, audio, or source element, or track element. There's a lot of new advanced ones. I call them advanced directives. They don't really fall in with the others, but they still provide a lot of security benefits. One of the ones that gets mentioned a lot is frame ancestors. You can use that as your new XFO tag or header, which is X-frame options for working on like UI redressing attacks. But they also have things like child sources, form actions, like where URIs can be used as the action of an HTML form element. You can treat your content as a sandbox. You can specify how you want the refers to handle so you don't get refer leaking when switching between mixed content. The plugin types, so like if you only want your page to load PDFs or X-Shockwave Flash or something like that. And then you can also instruct the browser on how it should handle XSS reflective protections. So like we talked about XSS Auditor a minute ago, you can say, hey, I want you to only block, or hey, I don't want you to use the blocking of this feature, which is really similar to the XSS protection header. So this CSP kind of gives you 3 headers in one, which is kind of cool, in the new version 1.1. And so what we'll be focusing mostly on is this thing called the report URI. So the report URI is an endpoint you can specify so that when there is a report violation, your endpoint will know like, hey, what went wrong, and it gives a nice detailed report with a lot of information, which we're covering. So there's also some directive values. Most of these are also self-explanatory. Host, like we saw in the previous example, so a directive can have a value of a host, which is like bootstrap.com or jQuery.com. And hosts are unique by scheme, host, and port. Then there's wildcard or star, which means you can accept values for this directive from anywhere. Then there's the none type, which is the most secure. If you could have none, that's fantastic. It just means don't load resources from anywhere. Self is from the same place, so scheme, host, or port, the same scheme, host, and port. And then you can also specify things like scheme. So if you only, like a lot of times when you see image, so image source, you'll see that it'll only allow data, which is like if you have an image representation like base64, that's fine. Normally that would be blocked by something if you have like a none for image source, but it's saying you can load image that have the type scheme data, or you only want to load things that are over HTTPS, which is pretty common to see for like images. Some more directive types. So when a browser receives content from a website, is there any way it can differentiate between if that content came from an attacker or from the server? And obviously the answer is no, because if it could, then we wouldn't really have XSS. So when you're looking, when the browser receives this HTML and it sees inline JavaScript, there's no way that it can tell if this JavaScript is good or bad. And so because of this, you actually have to remove all inline. It's just one of the downsides of CSP, but it's the way it has to be. So if you, for some reason, must have inline JavaScript or style sheets, you can use this directive called unsafe inline, and that'll allow you to do this. You lose a lot of the security benefits of CSP. There's other reasons to still use CSP besides this XSS protection, like we talked about XFO and XSX protection headers. But this is the main benefit of CSP is XSS, and having unsafe inline kind of negates that. So there's also unsafe eval. CSP by default blocks evals, set timeouts, set intervals, new functions when used in string format. This just allows arbitrary execution of code. You can still use set timeouts and set intervals with a function, just not with a string. So 1.1 also introduced two new concepts, nonces and hashes. Sometimes you have like a Google Analytics script on the bottom of your HTML page, and you want to allow that, you just don't want to move into its own thing because it's static, its own JS file. So you can now add nonces, and so these are just random identifiers, kind of like CSRP tokens. What these allow you to do is you can have like a script, you see, and right there it says script nonce is equal to this, and in your header you just say nonce of this value. And so when your browser is rendering the HTML, if it sees something with the nonce value, it just checks the header and makes sure those two correlate. If it does, then it allows the script to execute. So you can do that with nonces, just make sure they're random. And you can also take the hash of the contents of the script tag, and if the contents, the hash of the script matches what's in the header, so you say like SHA-256 is a big value, if those two match, then the script will also be allowed to execute. So two different ways you can have inline. You still have to be careful with them, but they're out there. So if you built a policy, you've probably, and installed a policy on a website, you've probably seen something like this. This is Twitter. If you were to use a really bad policy, you can see it's really messy and gross. Probably not what you want. And you probably saw a lot of violation reports. Or if you looked at your console, you saw a lot of like these red error messages telling you what you had done wrong. And obviously, this is not what you want. But the violation reports are actually super useful. They tell you exactly where the problem is. So when you have an error message, first thing you'll notice is in your console, you'll get this, refuse to load style sheet. This was on my blog, and it said they didn't want to load Bootstrap because it violated the content security policy directive default source none. So nothing was allowed to be loaded, and so obviously a through message. If I had a report URI installed on this policy, it would also send the report with the following fields to that endpoint, and it's all in JSON. So it would have a document URI, the URI of the document, which was where the violation occurred, the refer of the document in which the violation occurred, the blocked URI, so the resource, the URI of the resource that was blocked, and then the violated directive and the original policy, which is all pretty self-explanatory. So, but actually these reports actually turn out to be extremely useful when building a policy, and you can actually have these reports do all the work for you when building a policy. So when you receive a bunch of reports, these are kind of sample reports up at the top. You could suppose, like, let's say you set up a report URI and you set a really restricted policy. You're going to receive a whole bunch of reports, and they'll kind of look something like this. So you'll see you got a blocked URI of Bootstrap that violated the directive of style source, a blocked URI of Bootstrap again that violated directive of a script source, a blocked URI of jQuery with the violated directive of script source, and two others. And so using these values, it pretty much tells you exactly what's going wrong with your policy. And so if you just parse this JSON, you can build a policy directly from it, and which we're going to talk about a little bit later, which is the tool that I use to take care of some of these problems. Another problem you'll have is when installing a policy, every single client you use is going to receive this policy, and so if there is something wrong with the policy, you're going to see a lot of reports. So an example, if GitHub was to install a policy with the report URL at csp.github.com, every single client that gets that policy is going to send violation reports to csp.github.com. So you're going to get a lot of duplicates and a lot of data really fast, and it can be kind of frustrating to go through. So when building a reporting and policy mechanism, it's important to have some sort of aggregation function so you're not just looking at the same data over and over and over. Some other problems with CSP reporting, normalization. A lot of browsers have their own little quirks. They're actually really not that bad though. Sometimes they might just have an extra field or something. I never really saw, it didn't really seem too bad. One thing that's pretty helpful though with normalization is on the document URI and block URI, sometimes they'll have paths and they're really not too important. Usually you're just kind of interested in the domain. So usually on Caspr anyways, those get stripped down. And then also pretty useful for normalization is when you get these reports, you get reports for different reasons. So like you get a bad eval, like a JavaScript eval that shouldn't have been there. Maybe it's blocking a host or maybe it was inline. It's kind of useful to classify them when you receive the report. And this is from Neil's blog. I'm sure Neil Matatal, one of the runners of this event, used to do a lot of CSP at Twitter. And I've seen this too. You get a lot of junk in your CSP reports, like ISPs might be injecting crap. Sometimes you just get random ads and you're not really sure where they're from. A lot of just clients, maybe they have malware on their system that are generating reports that you don't want. There's just a lot of noise in the reports, so you want some way to filter those out. And so, along with the information that's included in all the reports, you also get a lot of information that you can kind of glean, like meta information. So you get the IP address of the client. I don't really think it's too useful. Maybe if you could prove that like certain IP locations are more susceptible to like ISP injection or something, but it's there if you need it for some reason. Another useful information gained from reports, since it's an HTTP post, you can also grab user agent screens to see like how different browsers are handling different things. Of course, you can grab the timestamp, which is also very useful. Build the classification off of how the browser sends them, so you can look at like if the violated source was empty or not. You know if it was an inline, or if it was an eval, or if it was a blocked host. And then another thing you can do with violation reports for the URI is you can add a query string, and so whenever you receive a HTTP post to your endpoint, you can see that query string, and you can use that to identify where the violation report came from or any other information about that client that you wanted to see. So that's the background of report URIs. Now we're going to talk about Caspr. So I was building a CSP reporting system back at MongoDB last summer, back when I was an intern there. They had a couple of internal tools, and they had a lot of XSS problems that I got to have fun with. I built my own little sandy worm, and they had like a little profile page, and I made a couple like clicking attacks. And so eventually they were like, Stuart, you need to stop doing this, and you need to go fix all this stuff. And so at first I was just gonna like do what normal people do, is check the encoding, and filter it properly. But eventually someone was like, hey, you should check out content security policy. So I tried doing content security policy, and over the course I ran into all these problems. Like I tried building a policy, and it turns out building a policy is kind of hard, and you end up with a bunch of websites like this, and it's very frustrating, where you'll end up with like too many reports, and you're not really sure what all these reports mean. And so that's where Caspr came in. And so that was my accumulation of work that I did for a little bit at MongoDB. So the background of Caspr. So building Caspr policy is a lot of work. Like I said the problems earlier, it's easy to miss something. You have to manually check each page for the content, make sure you're loading everything correctly, and reports can be confusing. So the idea behind Caspr is what you can do is instead use those violation reports to your benefit. Instead just install a ridiculous policy on that website, collect a whole bunch of reports, and then Caspr will just filter through those reports and build the policy for you. Make it way simpler instead of like trying to find everything. So Caspr does three things. The first thing it does is it's an endpoint for collecting CSP reports. CSP reports sometimes aren't parsed by all the frameworks correctly. They have a MIME type of application CSP report, which doesn't get handled by like Node.js by default, which is kind of frustrating. So Caspr handles little bugs like that. It's an API for managing and downloading CSP reports. So it's like it stores all the CSP reports, and it makes an easier way for you to grab them, and easier way to manage them. And then of course it's also a front end for viewing and aggregating and filtering the reports. So you can find it on GitHub, Conrad Caspr. It's standard mean stack, MongoDB, Express, Angular, Node.js, hipster tools, but not so much hipster anymore. And so, first thing up, it's an endpoint. So it creates endpoints per project. I'm going to go through installing a CSP, or installing a CSP on our website in a minute. So we're just covering this, so then we'll show you how it actually works. But it creates endpoints for projects. So this is the report URI you'll use once you have everything set up. Every report received is on the endpoint is normalized, classifies, filtered, and filled out with the auxiliary data. And then I use MongoDB on the back end, so all the data just goes into a MongoDB collection. Like I said, it has a RESTful API. You interact with the service through the RESTful API. I put like a little front end on it, which we'll see in a second, but pretty much all that's doing is interacting with these routes that are on the back end. You have RESTful API, so it has 4 things it consumes. Well, the first one is projects. Each project should probably have, when you're building a new policy string, that's when you create a new project. And so you'll have a project for like pretty much each website you want to install CSP on. So you can create new projects, get new projects, delete new projects, standard sort of RESTful stuff. You can grab all the reports for a project or delete all the reports for a project. And then you can also get the groups. So like I said, when you send or when you install CSP on your server, all of your clients are going to get that CSP policy. And so you're going to generate a lot of reports, and a lot of those reports are the exact same. So what Caspr also does is it aggregates all those. So any report that looks similar just kind of groups them together and creates a histogram for you, since you don't want to filter that out. And then you can also get any group that's associated with the report, which I'll kind of show what that looks like on the front end. And then it also does filtering. Like Neil said, other people have seen, like 66% of the reports you're going to receive are garbage. If you put it in prod, if you do it on your own system, you won't have too much garbage. But if you do it on prod, you're just going to get a lot of garbage, and you're not really sure what it does. So filters are a way to kind of get rid of all that garbage, so you're only looking at real data. So now we're going to mess around with Caspr. So to get to Caspr, just go to github.com/. There we go. Here you go. So go to Conrad Caspr. Down here there'll be a little button. I used Heroku since it's really easy for other people to set up. Basically, just click this button. No! One second. I'm connecting. Sorry about that. It's connecting right now. There we go. Okay, cool. So this is Heroku is just a platform as a service. Basically, we're gonna create a new project. All right. Deploy for free. It's free if you want to set up Caspr. You just have to create a Heroku account. And so while this is setting up, we're going to talk about the next tool because it takes a minute. Go back. There we go. We'll come right back to it. So one of the problems is when you're installing CSP, it's kind of an iterative approach. You're going to be testing a policy out, and that policy always doesn't work at first. So then you have to go back to your server and actually manually edit your server and change the policy screen, which is kind of frustrating. So I hated doing that over and over and over. So I created a little Chrome extension called Enforcer, which doesn't show up the best on the screen, but basically it's a Chrome extension. What it does is when your web browser makes a request, it sends like a GET request to Facebook, get index by HTML. Your Facebook web server responds with some content, like HTTP OK on the bottom right with the content type, a bunch of stuff. Then Enforcer picks it up, and Enforcer just enforces whatever CSP policy you want to kind of make it look like it came from the server. And so you can rapidly test CSP policies on other people's websites that you don't even know, which is super handy. So like you can test CSP for a web server you don't own and build a policy for them, and then you can just hand them the policy string and be like, hey, here's the policy that'll work with your website just fine. So like I said, it's a Chrome extension for building a policy. Intercepts web requests. It's built in HTML, CSS, JS, Angular, and you can find it on Conrad Enforcer. Enforcer. If you just Google CSP Conrad Enforcer, it'll pop up as the first thing. Cool. Okay, we're gonna go back to the demo thing. I think I might have. Ooh, there we go. Finally. Okay. So, oops, we'll go back. So this is Caspr. It just gives some information about what CSP is and stuff that you already know. So we're going to click Get Started. So first thing you do is create a project. I was thinking we could install CSP, or sudo install CSP on the scheduling app, the AppSec California 2015. I saw that doesn't have CSP, so we'll just install CSP on that. So AppSec, the scheduling thing. Okay, so here is the first dashboard. It's kind of coming in fuzzy, but here is the policy that you would add to your website. It gives you a list of the reports, the number of unique reports, because a lot of the reports will be duplicates, some actions. Eventually we're going to have like import and backup and all that stuff, but it doesn't really seem like anyone wants it. And then some settings, hiding projects, which I'll talk to you about in a second. You can delete all the reports and delete all the projects. So first thing you do is you capture this policy, and you go back to the website you want to test. And so this is the little Chrome extension up here. You just click that. This is Enforcer. So what we can do is we want to enable it, and we want to, this is content security policy. So you can run content security policy in two different modes, as enforcing the policy or report only mode. In report only mode, when it finds the violation, it sends the violation report, but it doesn't actually block anything. It's useful for like, if you want to roll out CSP, but you don't want to disrupt your users because you're not exactly sure how to work out, this is perfect because you'll only get the reports. But we actually want to, and we don't care, because this isn't real. We're the only people that are going to be seeing this report. So we set up this pretty, not obtrusive, but pretty strong policy. It has a default source of none, meaning it doesn't allow anything by default. But then it says allow script sources from self. I assume that self is safe. Allow connect source from self, image source from self, style source from self, font source from self, and the report URI. And so Caspr automatically fills all that in. So we've refreshed the page. Now that it's enabled, okay, popped up. We can see it looks like mess. This is exactly what we wanted. I got a whole bunch of, that means all the reports were blocked. We can see it kind of down here, kind of hard to read, but basically these are saying like inline script was blocked, more inline scripts, maybe some content was blocked, exactly what we want. So if we go back to Caspr, refresh, we can see, woo, from a couple page refreshes, we got 36 reports. Fantastic. And so I'm just going to refresh this a couple more times, just so we get some more reports. We can take a good look at Caspr.
At what point does Heroku start charging you?
It doesn't.
Really?
Yeah, it's just free. Yeah. If you want to scale it up though, I think it's like $35 per instant if you want to scale it up to like 2 instances running behind like a load balancer, but Caspr handles about 30,000 reports without any problem. Once you get to about 30,000 reports, then it gets kind of grumpy. At that point you can just delete your reports and start fresh. Like, you don't need to hold on to all those old reports. Anyways, so we have 45, good enough. Anyways, we go down to this Analyze tab. So here we have like nice little graphs. I'm sorry this is coming in fuzzy, I wish it came in a little bit better. But it just tells you the type. So this is it's a script source, an authorized host. We have a style source which was inline, it tells you where this happened. Image source, where it happened. You can change like how you want to look at the different data, like you can monitor your policy, how it changed over an hour, a day, a week, a month. That's what this says here, hour, day, a week, or a month. And then you can also change the bucket size. So it gets a timestamp of when it was received. You can say, I want you to group reports into buckets. So right now it's looking at bucket size of a minute or an hour or a day. And so right now it's looking at all the reports that happened today, and each bucket is of size of an hour. So we did it at like, I guess at 10:59, a little bit after 11. So you can see things in 2 different buckets, which is perfect. And then you can look at specific directives. So if you only want to look at like scripts or something, you can turn it on and off. And then the group limit number of graph series. are just different ways to look at the data. So here are the actual groupings of different reports. Sorry, it's hard to see, but so this first one says image source. It has a directed type of image source, and it says the block to array was static.sketch.org. And so you know exactly what's wrong there. Tried to load an image from static.sketch.org, but it didn't allow it. You can look at some details. This will tell you specifically for that report how many of those reports you've gotten over time and what they look like. So it kind of groups everything up for you. Which is nice. Going down, here we have a script source. Right here, script source that was blocked from s7.addthis.com. So another thing we need to add, another script source from cdn.schedule.ws. So just a useful panel, tells you where everything is. So up here is the policy builder. So right here, this is the policy that Caspr last saw for this project. That was the one we put into Enforcer, this little guy. And this is the proposed policy that it thinks that you can maybe use. So pretty much you just go down here, it took all those reports and guessed like, hey, these are the things that are being blocked, so we should add these to your policy. And so you should go through these though, make sure that you don't actually have anything malicious. But this is, it says, hey, should we allow something with the origin of HTTPS static.schedule.org? And of course you want that, sure, that sounds good. You can kind of see how it changes. You can't read it, but you can see how it changes. And basically it's just adding that host to your proposed policy. Over here, it says cdn.schedule.ws. For an image source. Should I allow images from there? Sure, that sounds good. We'll add that one. Do I want to add scripts from this one, this one, this one? Sure. And styles from here. So fantastic. So using this, it added all those hosts to our policy. So we can go back to Enforcer, and we can test this new policy out. And so I just put the policy in here. You can see it kind of sorts it by directives, if you find that useful. And we'll refresh. And so, woo, the web page looks a lot better now, which is fantastic. So we got a lot of the content. There's still some things wrong. Like I think these are supposed to be on the same line, and there's some mess over here. But it does look a lot better. On the bottom, we see we get a lot more errors still. Most of these. So actually, we'll clean this. So normally when I install a new policy, what I do is I just go and delete all the reports. All the reports are from the previous installed policy. So I just delete them. I don't see any need to hold on to them anymore. If you want more reports, you can just generate them later. So we'll clear that out, and then we'll load some new reports. We'll come back to Caspr. We'll see we now have 60 reports. Most of these, if they don't have a block to run, that means they were either an inline or an eval, which we'll talk about in a second. But we'll see we have another piece of content loaded here. A font source from cdn.schedule and a font source from fonts.gstatic that didn't get included. Usually because like some JavaScript wasn't working or something that later requested. But now that we have JavaScript sort of working, we can re-include it, update our policy. And there we go. We'll look at the reports again. Oops. So basically just hit refresh it once to generate some new reports. So we'll go analyze the reports, and at this point we see that since there's no block to arise, we've successfully included all the external hosts that we want to include in our policy, which is fantastic. So now all we have left is including script sources, or inline scripts, inline styles, and JavaScript evals. So you can go to the inline eval helper. This will tell you where all your problems are. So this first one right here, it says, since there's a source file, that means there's an eval located in cdn.schedule.ws on column number 597, or line number 590, or 567. You can get more details about this, and just kind of tells you how this report has changed over time. But if we really want to, I mean, we could go to this. You could go look at this file and you'll see the eval there. I'm guessing this is an externally included script from somewhere. Hopefully you can look at that eval, see if you can remove it. Hopefully you can. If you can't, which seems to be the case a lot of the times, you can use an inline eval. But something to keep in mind. The next one we look at here. I actually did go and look at the source here. It's just an eval right there. So it didn't look like it was doing anything that important, so hopefully you can remove it if you were this website owner. The next one is it has 5 counts. It doesn't give you a line number, a column number, or a source file, which just means it's inline. So if you go and view the page source of this thing, right on the main page. Oops, sorry. Right up here, there's some inline JavaScript, kind of hard to see, but that's what's filing a lot of reports. If you go through the document, there's just a whole bunch of inline JavaScript. Unfortunately, the website owner is going to have to go through and remove all those, but that seems to be accounting for the rest of the script sources, is that inline. And then the next, you look at directed style sources. These are just inline style sources. You go through, you remove them, and you call it good. And now you have the CSP policy installed. And so from this point on, what I would do is just go out and clear all the reports. Once you have your official CSP policy done, go to your web server, put it in report-only mode for a while, just so you can kind of see how your clients are going to handle it, see if there's anything you missed. But other than that, put it in report-only mode. You monitor it, just go to analyze, see what happens. If everything looks good, put it on the enforce mode. So just CSP, not CSP report mode, and see what happens. At that point, you should have CSP installed, and your website will be a lot more secure. One thing I didn't mention, filters. Let's go generate some garbage real quick. That's not. Design fun block. So I'm just generating reports so I can show you how the filters work, but we need a good. I don't actually have any garbage right now, so normally I would like to show you garbage, but this website just doesn't have no garbage is being injected, so we don't have to worry about that, which is good. So let's say for some reason you were getting a lot of blocked URIs with this value. This value is s7.addthis.com. Maybe it's an ISP or something. You don't really know where it comes from, but you don't really care about it at all, and you just don't want to see reports related to this. What you can do is go to filters. Hard to see, but basically you're giving the filter a name. I usually just give it the host name, and then the field that you want to block. So this says blocked URI, and we're looking to block the URI, and it just accepts a regular expression of what to look for. So you just put in the host, you add the filter. There's your filter, which is pretty useful. You can click on more. So this says this is the host name. It says that it's looking for fields of blocked URI, and this is the regular expression it's looking for. You can click on more. It shows that it's blocking 2 reports that match this filter string. You can edit it. These are inputs, and here are the 2 reports it's blocking, or the groupings of reports. So if you go back to analyze, you'll see that this thing no longer exists, which is what you want. So filtering worked correctly. So that's all of Caspr. Check it out. It's free to use, open source. It's on GitHub. Use it to install CSP policies. Cool. Okay. So we just did demo part 2. So the future. So I got some feedback about Caspr. A lot of people seem to be using Caspr. They like it, which I think is fantastic. So it's still there, freely available. Some people, they have their own log viewing tools. Like some people want to use Elasticsearch or Splunk or something like that, which is fine. So I started creating this thing called CSP lists, kind of taking all the components of Caspr and kind of dissecting them and taking them out. Because some people only wanted reporting, some people only wanted filtering, and so started building this thing. It's pretty much done actually. It's the CSP lib, and these are just all the little components. So CSP parse is just a Node.js module for parsing and extending policies. It's what Enforcer uses up here, this little guy. So if you go to default source and you actually want star or something, it's kind of what builds the policy and manages and makes sure that policies look good and corrects any errors. The actual policy strings. There's CSP Storm. This is for generating violation reports really quickly for testing your endpoints and testing your filters. It just generates a bunch of really garbage-looking reports really fast, just to make sure everything's working correctly. CSP endpoint. This is just a command line tool. You just say CSP endpoint. It creates an HTTP server for you with an endpoint name. You can set that as your report URI. Collect all the reports, and it just dumps them out as JSON. It grabs all the fields, does classification, and so what you're left with is just a command line tool that pops out a bunch of JSON, with all of your reports. And so then you can feed that into a file, feed it into whatever log sort of Elasticsearch thing that you use that you like. It's actually a pretty helpful tool. CSP filtering, a lot of Neil and I were talking about like different field attributes or different policies that we see a lot, or different reports we see a lot that are usually just garbage and can be discarded. We're putting those in CSP filters so no one else has to look at all those garbage reports that we don't think are useful. And then two other libraries that haven't started are Express CSP nonce and Express CSP hash. These are just Express middlewares, so that'll generate nonces and hash values for you. Kind of also work based off of what Neil did, but I think he did his in Ruby. And just an Express middleware, so if you must have inlines, these are kind of a framework for you to kind of tag things that you want to have nonces and things. You can tag things that you want to have hashes, which I wouldn't exactly recommend. It'd be best if you can move all the JavaScript outside of the HTML files, but sometimes that isn't always possible. So once that's done, I think it's right now they're in GitHub/Conrad. I think I'm going to move that over to GitHub CSP libs. If anyone's interested in Devin, just shoot me an email. I'd love to have more people working on it. But other than that, that's it. Today we talked about single origin policy, content security policy, how it generates or reports so you know what's wrong. We talked about the two tools, Caspr and Enforcer, and the new collection of tools that is coming out. It is out, but you don't kind of see right now, called CSP tools. So that wraps up the presentation. Are there any questions?
You thought all about generating CSP policies for different international domains. For example, Airbnb.com uses like Google Maps, and so we whitelisted all of Google's API endpoints for their US domain, and then we're using the same CSP policy on, like, let's say our Hong Kong site or our French site, but there Google is making requests to its French or like East Asia API endpoints, and so we're getting a bunch of violations there. We have a good solution for figuring out all these different.
So what's throwing the violation? I'm not quite sure.
Google Maps will load tiles from Google's CDN, and so it's a different origin depending on your origin. But there's not exactly a one-to-one mapping from, like, let's say where your website is to what all its different, where all the different JavaScript on the page is.
See, it's not subdomain. They're coming from completely different origins. It's not.
They are.
They're from.
Like the TLD is different.
Oh, I got you.
So it's like Google.com is.
You can generate. Yeah, it's a very unique problem. Yeah, not sure what the best solution. I mean, you can include all of them. I mean, that's one solution right there. Just make a list, add all the TLDs, and put that in your policy. If you know like where the user is going to be searching, and you can change the policy per request. So if you know that the user is looking in this area and hopefully they're not looking in another area, you can include just those subdomains or just those TLDs. That's an interesting problem though. I'd be interested in taking a look if you want to shoot me an email later. But, any other questions? Awesome. Okay, well,
So you said you Caspr to use any kind of backend, or with use Mongo, that what other backend could you do?
So yeah, right now I inject everything in a MongoDB. Just so I built it for myself. But yeah, you get JSON, so you just get JSON strings. Anything, if you write a JSON parser to your own favorite backend, then you can use your own favorite backend. Yeah, you can put it to text file if you really want. It doesn't really matter too much. Yeah. Any other questions?
Like in the GitHub, when you download your version, this has to have the GitHub. If you want to deploy it, if you're using something else, you have to rewrite it.
Yeah, you would have to write code to do that though. Yeah, I've been thinking about that, just running a wrapper around the DB layer. Not everyone uses Mongo or likes Mongo. That's something that is on the chopping block to do. If you use the Heroku thing, that uses MongoDB by default, just because it's simple. You just click one button and it works. But yeah, you can deploy Caspr locally. It's pretty much just node min start, just one command, and it runs. So.
Yeah, so going on to the other question there, do you know of any resources for people who are embedding stuff like Google Maps or Facebook-like buttons or things like that, so that you know that you're embedding Facebook-like buttons, so you know that you'll be able to make your CSP changes like this?
I don't really know any resources. I can look it up, yeah. You just shoot me an email. I'm definitely interested in helping. Yeah, no. Any other questions?
I don't know if you're following the stimulus check. You know if there's like something out there where like if websites writing APIs where they detail all of the like where they basically say like add this to your CSP policy. It seems like would be a very useful thing for Google or Facebook or any of these other API providers to have.
I haven't seen anything like that, but I mean that'd be a good idea. I'm not part of the policy group. I'm just a student who read the draft and started building tools. Yeah, I don't really know CSP that well. I just build stuff. Any other questions?
Have you looked at the different frameworks that support CSP?
Yeah, unfortunately I use AngularJS, so I don't really worry about that too much. For everyone else though, I'm sorry. Yeah, you just have to put that eval statement and kind of bug them for a while. I know it was kind of frustrating. I think jQuery they might still be using evals. I think they got rid of them. Thank God. Okay. Yeah, like for a while jQuery still had evals and stuff, and so was breaking your CSP.
General and also CSP compliant.
Oh really? Oh nice. Okay. So there's another one. So yeah, talk to those people. Try to get it pushed out. I mean, they should have support for that. I mean, CSPs it's a very important thing, and it's doing a lot of great good. You think that these front-end frameworks would do a little bit better, but I'm sure they have their own schedule. What's up?
Have you had any instances where you've had process for people despite having CSP?
That's a really good question. There are still ways you can trip up, definitely. Like I said, you can have it using the header tag or using a meta tag within your HTML. The header is way more preferable because it's still possible to get an injection in your HTML. So like, let me just. Basically, let's say like you had a dynamic title generation. Your title is in your head block of your HTML. If you screwed that up somehow and your CSP thing was after where you specified your HTML title, an attacker could possibly inject a meta tag with a different CSP policy that would still get injected. So like, that's one possible example. Another more common example is if let's say you include anything from self, but you generate, and so you'll have a script like that'll be on self like app.js or something. If you dynamically generate app.js, it's still possible for attackers to put an injection in app.js. It'll look like it's coming from the server and it's valid. So make sure if you're still. Does that make sense? Okay, cool beans. So one of the things in the policy it says is that CSP is a defense in depth. You should always make sure that you're using filtering on the input and encoding on the output. So if you are doing dynamic generation in something like app.js that's loaded on the server, it's still possible to get an injection in there because they're still able to execute or inject JavaScript into your JavaScript files. Okay. Long-winded answer, but thank you. Any other questions? All right, well, thank you all for coming out. Thank you for the questions. Caspr or something, just feel free to shoot me an email. My name's Stuart, Larsen, or Conrad. I'm on GitHub. You can Google me to find me. Thank you.
We had like a certified normal one for I want to find you out. So they sought to and like every time we get to a log, we had to talk about CSP. Everyone is like, does somebody have a list of filters we can just put somewhere? And everybody's like, no, you should build that. And so